Hmm. Hello, good evening. How are you? Good
I'm
morning.
good. How are you?
I'm great. Let me, yeah. Could you see the presentation?
Yeah, I could.
Okay, great, great. No problem. So, where were we? Okay, let's be there. Sure. Let's get started. So, we have. mm, so, Kaushik, could you please tell me what do you mean by, like last time we discussed, right? What do you mean by intelligence overall?
Like intelligence is like how like smart something is, or like how much stuff does like the object know. For example, like a computer, and a computer's intelligence is how much stuff something knows,
Mm-hmm.
or like how smart it is, or like what it's able to do.
Right? No, no. We basically, discussed definition last time, right? Could you recall that? I've asked you to write down and all. Could you refer to that? Last time we have written a definition, right?
Yeah.
Could you get that paper or register pen? Hi, Ishan. Hi, Darshil. How are you?
I'm fine.
Hi, Darshil. Are you there? Again, same mic problem. Um, could you recall the definition we've written for the intelligence? What do you mean by intelligence? Last time we have written down. Could you read it for me?
Hello, sir.
Yes, sir.
Yes, sir. What was the? I'm fine, sir.
Yeah, last time we have written down a definition of intelligence.
Yes, sir. The mental ability necessary for adoption is intelligence.
Perfect, perfect, perfect. Could you explain it in more in your words? What do you mean by adaptability? Any example? We discussed quite a few last time, right? See, we are going to build our thought process on basis of these definitions, these discussions, right? So if you miss the previous one, then it'll be difficult to learn new one. That's why I'm insisting.
Is it like the
Yes,
ability
Kaushik.
to adapt
Yeah,
to?
come in, please. Sorry.
Is it like the ability to adapt to?
Perfect, perfect. How could you explain in your words?
It's like how the robot is able to understand its surroundings and able to change itself to work with the surroundings and able
Right.
to like do
Change
its
is other
job with the
part. React
surroundings.
to is the first part. How do you react to and then change to? That's okay. Perfect. No problem. So just write down there how to react to given situations. If you miss that, because adaptation, there's a reaction and there's a getting adjusted to. There are two things, right? So first step is basically react to the given scenario. Okay, and then we say the ability is necessary to adoption to as well as sharing and self environmental context and blah 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 blah. Let's not go to that level where we start being a geek, right? Let's try to understand first and then we'll be a geek. Once you understand what all it comprises of, then you can have all these additions to you. I'll give you a presentation, means don't worry on that part. You don't have to write these things. These are the definitions from various extracts. So I'm going to share with you and you can go through it whenever you have a time. So there was a small homework last time, right? Non-technical homework. Have anybody spent some time on that? Have anybody addressed that homework? Yes, Kaushik?
There's like the Maimu car like uses cameras like around the compute like around the car So whenever it senses an obstacle,
Isn't it, Mummy?
One by one. Just, wait, Darshil, let Kaushik complete, and then, we'll come to you. Please go ahead, Kaushik.
and after it uses its cameras around the car, it's like if there's like an obstacle, if it sees like an obstacle in its way, it's told to stop, or it's told to move away from the obstacle.
Okay. If I give you a camera, can it basically understand obstacle? You have a camera in your mobile, right?
Yeah, but it can't understand an obstacle. You have to use like a
Yeah. So
computer.
camera is not the right answer to that. Camera couldn't, what you can say, understand obstacles. There are some other ways. We will come to that. Okay. But so as a human, right? As a individual, how do you understand obstacles?
You look at the obstacle and you look, and if you see an obstacle,
Mm-hmm. And then you would say, because you have two eyes and all those things, right? You basically create a perception of obstacles in your mind, and then you start avoiding it whenever you walk down or you're progressing on that. That's really great. Okay, now we are going to learn what are sensors, how we can utilize this sensor, what are different type of sensors in robotics, and how we utilize these things. As a human, we are very evolved being, right? That's what we call being. We are living beings. But in robots, you need to use 15 16 different sensors to just create an illusion of obstruction. Let me let's go there step by step, right? Let's go to Darshil. So please tell me your understanding of obstacles, how driverless car can understand obstacles in front of. Are you there, Darshil? Oh, okay. Ishan, could you go ahead, please?
Open नहीं कर सकता.
Okay, yeah, go ahead, please. We can hear you. Darshil, we just heard a couple of words from you, that's all. Hello? Okay, is there a problem with my connection or something? Okay, he's my mic. Okay, no problem. Okay. Let's not do it in chat, because this is a discussion thing, so you can't do it in a chat. No problem. Okay, let's go. Let's go ahead. Ishan, could you unmute yourself, and could you? Yes, we might need a laptop or computer, because phone is not more than phone is not sufficient. Okay, Ishan, could you please go ahead? What do you think about how an obstacle can be addressed by a car, autonomous car?
Sir, by sensors they can sense how far the object is from them.
Right.
And
So which type of sensors, if I may ask?
I don't know.
Okay. Do you think your mobile can see obstacles?
No.
Mobile have quite a few, sensors, right?
Yeah.
Okay, mobile can't. Okay, no problem. That's really great. Let's wait for the shield. If the shield can, Okay, let's try to understand one by one. Could you see the image on my, screen? I'll just, Okay, now let's try to understand what are the different types of sensor. We are just trying to understand sensors now. This is a driverless car, and we're trying to get it run. This is quite old photo basically, and we're just trying to understand how machines or how robots try to understand obstacles. With the coordination of all these, mumbo jumbos, let's try to understand one by one. On the top of it, it's called LiDAR. It's a light emitting, or let's call it a laser gun. So there's a laser gun who is basically addressing any obstacles coming in the car's way. Let's try to understand what a laser does. Have you seen laser, the x-rays? Have you seen x-ray photo?
Yeah.
Okay, so what do you see in x-rays?
Like you just see like the bones, you don't like see like other stuff.
Okay, and how do you see the bone? Because whenever that camera captures something, you set up a distance, and there's a reflective. If you have your dental X-ray or any X-ray, there's a special plate at the back, and there's a special camera quite near to your skin, your bone, or your teeth. If you ever seen these X-rays. So why they do that? Because it's a distance-based photo capturing, right? Now, this is similar principle in LiDAR. We have around 10 to 20 laser scanning throughout. It's keep rotating. If you've seen, autonomous car, there are these, one or two or three LiDARs rotating on top of it. These are basically kind of laser guns who measures the distance, just measures, nothing else. So it just measures the distance from that gun to the object, which is it's interpreting. It's a kind of laser. Laser gets reflected back. It's a light image. Laser is a light, right? So light gets reflected, and that it try to measure the distance, and that's how it creates a 3D model inside its memory, and try to address these distance of each and every object you are addressing to. And this is a one way of. As a car, we need multiple, right? Because there could be some moving objects, there could be some stationary objects, there could be some lights as well. Because whenever you use something like lights as an measuring distance, and you have another light, so it'll be it can interfere with the system. So you need another system as well. So you have some sort of camera. Now these are what they call infrared cameras. Okay. Now in infrared, or all ultrasound cameras, let's try to understand infrared first. Infrared is basically these camera. They work in a different optical range what human couldn't see. So there are certain lights called heavy blue or very light white and all those things which human eyes can't see. So these camera try to capture those images. So if there's any moving image, if there's any moving object in front of this camera, they'll be captured that way. Okay. Now this is how we basically go into depth step by step. So we got a 3D model inside my computer memory to understand the obstacles. Could you understand me here? Have you understood that 3D model thing? You've seen the 3D model, right? You can see, these 3D models in various movies, or, or there are quite a few softwares, like they show you inside your house before that house got built and all those things. You understood what you mean by 3D model? Anybody who don't understand 3D models?
I understand it.
You understand. How about you, Darshil? Darshil, if you can, put your camera on, that will be great help. Yes, that's good. That's good. So, have you seen 3D model by any chance? Could you pull the camera a bit down? I can see your face completely. Yes, perfect. Now you can see, and I can read a bit of lips as well. So, have you seen 3D imaging, or 3D model? Okay, great. So you've seen. How about you, Ishan? We got you.
3D movie.
3D model.
No.
You haven't seen 3D model. Okay. How do you differentiate sphere from circle? You know sphere, right?
Yeah.
You know circle. Circle is a 2D object. Sphere is a 3D object.
Yeah.
Could you understand this?
Yes.
So if I want to show a sphere to my teacher, what I'll do, I'll get a ball, paint it. Ball means a football or any type of ball, or cricket ball or tennis ball. I'll paint it so, or stick some papers on that, and that's my sphere. Does that address your problem? How do you imagine 3D? Circle is my 2D. That ball, whatever you wrapped with the paper or whatnot, or if you have any coating on it, it looks like a sphere and all. So that's my sphere. Okay. Now, whenever I'm trying to understand these obstacles, I need to work out which direction, how far. So that's what I do. I normally create a 3D model of the surroundings inside my computer. Can I do that with these multiple LiDARs, multiple laser guns? Could you understand what I'm trying to say?
Yeah.
Great, no problem. Let's take a step further. Then there's something called radar. Have you heard of these radar thing? Anybody?
Yeah.
Yes. Where do we use radars? Okay, Darshil knows that. I understood. Yes, Kaushik. Where do we use radars? Ishan? Yes, Darshil, you're right. You got it. Aeroplanes, ships.
Aeroplane.
Okay. Yeah,
Tracking aeroplanes and ships.
exactly.
Tracking
Got the
moving
point.
vehicles.
Echoes, that's right. We normally read these echoes with radars. Radars is an ultrasonic frequency, and from where, if you have seen, there's a big, what you can say, C-shaped antenna revolving at a speed of, let's say, 2 RPM or 3 RPM. What is RPM? Revolutions per minute. Revolution is basically one circular movement, right? Per minute is my 1 RPM. So these are not very fast moving, but yes, let's say they max go at 20 RPM, means 20 revolution per minute. I'm talking about 60 seconds, right? So these kind of, what they do, they fire these ultrasonic waves so that they try to capture if there are any specific, moving objects around them, and they try to plot a 2D graph. Or now we have a radars which can plot 3D graphs as well. But these radars normally specifically built for moving object. LiDAR I normally use for stationary object. Radars, which we can't create 3D models, but we can create a 2D model. So what I'll have a plane and I have another plane. So in between these two planes, how many moving objects I have, that I can get it from radars. LiDAR is basically creating a 3D model, but LiDAR is not really very corrected in terms of moving objects. So for moving objects, I use radar. LiDAR I use to create a complete 3D model inside my computer. Radar gives me actual distance from my whatever object to that object, even if it's moving.
I have a
Okay,
question.
please go ahead.
If there's light, could you use a LiDAR? Because like, doesn't like the lasers from the LiDAR interfere with the light and like it won't like map a proper 3D image?
Could you please speak a bit louder?
There's light between like the object and like the LiDAR. Would like the LiDAR not be able to work properly? Because like the lasers would like interfere with the light and the light will interfere with the lasers and like it can't create a proper 3D image.
That's really great questions. Do you know something about frequency? Have you heard of frequency?
Yeah.
Okay. Frequencies, there are some sound frequency, there are some light frequencies. Light is a faster. Radar is a LiDAR is a laser gun. Radar is an ultrasonic gun, or it's a sound wave. LiDAR is a light wave or a laser wave. Laser is a type of light. Radar is a type of sound. It emits a sound. You know, right? That bat, how bat captures prey. Bat, bat, it's an animal, right? A black bat. It captures with this radar thing. The radar have been evolved based on the bat, the way they capture their prey. Means they, give a pimp-like thing, or I don't know, if you go to YouTube, there are really good video, and they normally tell you to basically understand that sound also. They throw a sound and their ear basically captures how far is the insect, or whatever their prey is, and that's how they capture. This is what the radar, these are sound frequencies, those are light frequencies, right? So sound we hear, light we see. For computer, they are frequencies. So computer won't mix them, because computer is a digital machine, right? Well, we'll learn about digital and analog in some time, but right now just like to understand light and sound are two different things. For humans, eye is basically sense the light, ear is basically for the sound. Are we good? Understandable, right? Radar is sound, LiDAR is light. Okay, and there are various things in between. Let's we'll learn step by step. Okay, and then there are other motion sensors. Now there are some sensors like pressures, there are some sensors like motion, there are some sensors like gravitational force, which can calculate height from the ground, and blah 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 blah. Okay, now on top of that, human also invented something called global positioning system. Have you heard of global positioning system?
Yeah.
Okay, great. So global positioning system is what that GPS is for. What this GPS is all about, GPS creates a squares on the earth. It's a pattern, it's get created by the satellite imagery, where they normally create a mesh, mesh, right? This is a square mesh which is created on the earth surface, imaginary, logically mesh created by the earth satellite, which are stationary on the earth for the earth. Okay, in US military it has a 5-meter mesh. In Indian military we have 21-meter mesh. So that's a square what is get addressed or captured by the satellite per revolutional basis. Okay, I don't want to go into detail those depths, but yeah, if you like to learn more about it, ask me and I'll basically guide you on that. This mesh is basically GPS. So how this GPS works? They works in X and Y. You know X and Y, right? So this is Y, this is X. There are axes. Now these mesh, what you can say, imaginary logical points have these, corners are basically labeled as numbers. So when I say 80.11, so there will be some square named 802 from vertical because it's X, and Y 11 square. So from my origin, whatever I'm considering as the center, 802 square down and 11 square right. Yeah, 11 square right. That's what this is talking about. It can be in negation also. So I can go to left because it's a 2D graph, right? It's a logical mesh. Here I can have a reference point and a distance from that reference point in 2 dimension, right? And that's what this GPS is all about. It can also track your mobile location because GPS is a service which normally creates a reference point from the satellite. That's the fun of it. Now they're trying to build it more efficient because these satellites can capture these images of that square on certain commands. So even US military, they have certain, repetitive image capturing to get their data of, let's say, a tide or, cloud movement in between Earth, Earth and that atmosphere. We have stratosphere and all those atmospheric layers. These satellites are above them. They are stationary, so they move with the Earth, right? So these keep clicking some pictures which guide you on environmental conditions, the heat ranges, and so on and so forth. There are a number of advantages of these geostationary satellites, and they give you these coordinates called GPS. Now this GPS basically guide you up to a level where your car should go to. So there's one point and there's another point. So there's my starting point and there's my end point, right? So could you relate? Could you reference your movement this way, right? From point A to point B. So 802, 11 to 803, 11 or 803, 12. I can move, right? Because these points are depending on those square mesh which are created by the logical satellites, satellites, and these points I can move on the Earth and get referenced by the satellite. Okay, I know this is a bit difficult for you. This is how it is used. So you can basically understand the movement on the ground with the satellite referencing. I know it might look like a dream to you right now, but this is how the GPS works. Okay, if you can't understand, forget it. The most important part is the computer can know if you're moving, if you're stationary, if you're moving at what speed, because computer can calculate, right? 2 minus 2, 0, 2 minus 4, minus 2, computer can calculate. So based on those calculations, we can have these speed, movements, and all those things based on the GPS. Okay, so what I got obstacles, I got speed, I got direction. This GPS can give you direction also. If you're moving, east, that's kind of x-axis. If you're moving, north, that's kind of y-axis plus. So there's a x plus, there's a y plus, y negative, x negative, right? So wherever you move, I can basically calculate in terms of movement, in terms of speed. Rather, I'll get something called velocity. Anybody know about velocity? Heard of velocity? And know the difference between speed and velocity? Speed is a scalar quantity. Velocity is a vector quantity, right? Darshil, do you know velocity? Speed? Could you recall? Perfect, no problem. So this is how we basically this is how our computer knows the positioning. This is how the computer knows the obstacles. Okay. Now there are various other sensors also. I need to make sure if it's moved, not moved. So there are some, couple of balanced out GPS there are a couple of motion sensors, pressure sensors, which will guide me in depth. We'll have a look at it step by step. Okay, let's take to the next slide. Now we have understood the machine, we understood the sensors up to a level, right? We'll take a depth about how many sensors are available and how we can check in the next couple of slides. But let's try to understand how this knowledge can be captured from a man to machine or machine to man. Now see, even in a driving cars, there are 2 or 3 modes: completely autonomous vehicle, semi-autonomous vehicle, and human guided systems. These are 3 things. Okay, let's try to understand. Completely autonomous, it's totally driverless. There's nobody guiding that vehicle except some robots or computer or predefined programs. And there's one called guided system. So there are some human supervising the guidance of the vehicle. And the third is basically there is a man who is driving that vehicle from a remote station. Like, you see that spy satellites, that spy vehicle, right? The US military uses what they call, I forgot the name of it. It's like an autonomous vehicle with just a fan and an elongated body. And they normally control it from almost, 1,000 kilometers or 1,000 miles away. And, these spy planes, they have cameras, they have all those, lidars and everything to basically understand all the movements of troops in the military, everywhere for that matters. So these are basically a guided system. So guided by human completely, they are not autonomous. Okay, so here how we basically transfer information from one to another. So human to machine or machine to human. And this is how we keep communicating. Now this communication is via some data link. So we use something like mobile devices to connect to data. We use wireless communication. Wireless communication has a limit. It has a limit up to 10 meters or 20 meters or so. So not sufficient. We can use mobile communication, but the data width is come. So data width is less, right? So we use couple of mobile devices, couple of communication channels which build on mobile communication technology like 4G, 5G, and so on and so forth. Right now, there are 6 research and development facilities in North America on experimenting on 5G. The 5G speed is 100 GB per second. The 4G speed is 4G speed is 100 MB to 150 MB per second. Now that's like kind of 100-fold increase in 5G. Okay, so there are ways of comparison. Let's not go there. Let's try to understand, if you're working with something like driver's car, there's a huge amount of data coming and going, the communication and the guidance part of it, right? I don't want to eat up your brains in, basically measuring this data points and all, right? But have you understood how that car actually works just in a layman terms? Now, could you understand how that autonomous vehicle is, moving from one point to another? What type of basic sensor they are using? Yes, Kaushik, could you please explain in your words what you understood about this autonomous car? There couldn't be any wrong or right. Please, just freely speak. Yeah, please go ahead.
It like uses like it like has like lasers around like the car that like revolves, that like finds the difference between objects, and like it can make like a 3D like object around. It can make like a 3D object of an obstacle, and then it uses like radars to detect any moving like objects around them, because like lasers can't like really detect moving objects, but like the radars can. And then uses a GPS to track like the car and to show the distance between like one point, like where the car is currently, and like where the destination that the car wants to go.
Perfect. So there are 3 important sensors: LiDAR, LIDAR, radar, RADAR. These are all acronyms. And GPS, Global Positioning System. These are the 3 most important sensors in a car. Okay. Oh man. Okay, let me go to oh man, where not here. I have created a slide to show you. Okay, here. Let's try to understand. I'll show you a video where we'll try to understand how these autonomous car experiment have been started. This is a bit older video, Give me a minute, and then we'll discuss. Stop and share again. I want to share Wyoming. Wait a minute. Oh, come on. Stop. I need to. Oh, wait a minute.
Back in 2009, in our early days at Google, we started working on self-driving cars.
Give me a minute, please. Why is this volume now? Oh, why is getting here? Come on.
Back in
Okay, let's have a look at this.
Back in 2009, in our early days at Google, we started working on self-driving cars. Today, we're called Waymo, and our fully self-driving cars are on the road. They use a range of technology we've built from the ground up to understand the world around them and get you where you need to go. You're about to see how it all works and what it feels like to ride in our car. As it drives, Waymo uses LiDAR, which sends out millions of laser beams per second to build up a detailed picture of the world all 360 degrees around it. It also uses radar to detect how far away objects are and their speed.
Could you sense the difference between the LiDAR and the radar? The distancing one, I'll repeat it for you. Oh no, this one. I'll share a link of this video also, so you can download and have a look at it.
To ride in our car. As it drives, Waymo uses LiDAR, which sends out millions of laser beams per second to build up a detailed picture of the world all 360 degrees around it. It also uses radar to detect how far away objects are and their speed. And high-resolution cameras detect visual information, like whether a traffic signal is red or green. It then combines all that data to understand the world around it. For example, in this fraction of a second, it knows exactly where it is on the road. It can also identify everything around it in full 360 degrees, and then predict what those things might do next. And it doesn't just do that for the objects you and I can see. It can do that for things up to 3 football fields away. What makes everything you can see right now possible is experience. Waymo has already self-driven millions of miles on complicated city streets, and it's constantly learning from every single mile it drives. With all that knowledge, it can plan a safe path ahead. In this instance, giving that cyclist enough room to cycle past us, and also looking out for that pedestrian on the sidewalk. And when it comes to making decisions, this is a good example of how Waymo doesn't just take into account your safety. It also makes sure that both you and the people around you feel secure and at ease. So now that you know how Waymo works, it's time to take your first ride in one of our cars. Take a look around. You're now riding in a fully self-driving car. Some things might immediately stand out. The fact that there's no one in the driver's seat, no one turning the wheel, and the screens, which show you what the car is seeing and the route it's taking. But you might also notice that the ride feels a lot like being driven in a regular car. And that's the way it should feel. All this technology, which allows Waymo to see, identify, predict, and plan, should make an extraordinary ride feel completely ordinary and create a very normal journey that simply gets you from A to B, safe and sound. And while it does all that, all you have to do is sit back, relax, and enjoy the ride.
Now, the fun part is basically, Google started this experiment in 1997. So it's almost 23 years. They are still working on it. to have a self-driving car, and they are still struggling. Means right now the maximum speed Waymo have driven to is basically, I think, 54 or 55 kilometers per hour, not more than that, and with something like ideal condition. These cars are not basically made for conditions like India and all. So they're still struggling with the obstacles in the calculations, in the distance and all those things, right? Now let's try to understand a Chinese, fellow who started a taxi service in last month, basically. I have that video for you also. This is really, give you an idea how a complete, wait a minute, how a good, autonomous car will look like. Believe me, these are also kind of theoretical conditions. They have not gone to a level where practically they have started applying it in actual public. But this will give you an idea where actually self-driving car technology is evolved to. Okay, and let's try to watch this video. This is really great video. How do you play it? Okay.
Welcome to Shenzhen, the Silicon Valley of China. Today, I'm going to take a ride with a completely driverless robot taxi driving on regular public roads. Let's go. And here it comes. The fully driverless robot taxi is making a U-turn to come and pick me up.
Now try to analyze what are things have to be automated, because you've ridden in a car, right? So you know what all it takes to sit in a car and all those things. But see the difference, see where we are and where we want to be. So I just want you to understand how technology should be advanced to go to this level, right? Because we are trying to understand how it's done, right? So let's try to understand my scenario. I have a car, and if I have something like this car, how can I automate that, right? Or just try to dream it about, and we'll discuss it further.
As we can see, the AutoX self-driving system is completely integrated within the vehicle platform. And this is why I can put my luggage here without any problems. This is a level 4 and level 5 fully driverless robot taxi from AutoX, the leading self-driving car company in China. This is a Chrysler Pacifica minivan equipped with high-resolution cameras, high-resolution lidars.
These two are lidars on the top. Like, you can see like horn, right? But there are 3 lidars. 1, 2 on top and 1 in the middle. So see how they are basically trying to evolve in terms of how the requirement gets evolved for a given robotics technology. We started with 1. There were 2 on Waymo. There are 3 on these cars, and there are radars down. There are 3 radars. Normally, a single radar does solve the purpose of the complete ATC, air traffic controller. If you've seen at airport, right? There's a big radar keeps moving at max 20 RPM and all. Here we are using 3 radars. Well, these are miniature radars, but these 3, try to understand how many sensors do we need. And each sensor adds the cost, right? Each sensor needs to be interfaced. It adds the cost. Each sensor needs to be basically collected the data from or given the instructions to. So see how complicated a simple thing like understanding obstacles goes. I want to understand those things. Like to build a robot is not an easy thing. You need to understand so many different points, so many different ways to make machine think, to make the machine analyze certain simple scenario as an obstacles, right? So we were trying to understand how this evolution of a self-driving car is taking place, right? And this is the latest one, which they say they're rolling out in public, but still they are struggling. This was a video taken around 21 days before. As is, Shenzhen is one of the biggest city in China. It's near that Wuhan where we got that COVID from. But yes, let's not go there. Let's try to understand advancement in technology.
And long-range radars. because it is a fully driverless vehicle, the car also has
Oh,
a
man.
surrounding blind spot perception system on each side of the car, including both wide-angle lidars and cameras. Here is the button to open the door.
你好，欢迎使用 Robotics 无人车，请您系好安全带，关闭车门，通过触摸屏进行操作。
Now I'm inside the self-driving car. The driver's seat is empty. The passenger seat is empty. The second and third rows are all empty. I'm in the car all by myself. This is so nice. Okay, now I'm all buckled up, and I'm going to click the button to go.
请先关闭车门，再开始行程。
Okay, it's letting me close the door. I'm going to click this button, and the door will close.
车辆即将开始行驶，请做好并系紧安全带。
Now we have switched the gear from P to D, and the handbrake is off. Now we're driving completely driverlessly.
Could you imagine the speed? It's not more than 20 kilometers per hour, 20 miles per hour, something like that sort. It's really moving slow. If you've seen the cycle guy who's cycling faster than the car. So try to understand the technology evolution here.
I feel like the car's driving really stably, and I have a good feeling about this. And through the screen, I can actually see that there are some 3D models of nearby surroundings that can show me what the road looks like without having to look at the front window. Now we saw some pedestrians biking across, and now we're avoiding them. Safety, hygiene, privacy, you have it all in this car. By the way, Robotics's Robotaxi is also the first fully self-driving car in the world that preserves the moonroof. You can open the sliding panel to see the sky. It feels so nice during winter to enjoy the sunshine. And you could also adjust the temperature from the AC panel right here. Feel free to help yourself. Now we're trying to turn right, and as you can see a pedestrian trying to cross the road. And our Robotaxi has determined that, so it's made a pause, and now it's kept going. Now we've entered the main road in Pingshan called Danzi Dadao. With a speed limit of 40 kilometers, we have now reached 40 kilometers per hour. Now we've bumped into a situation where there's a car stopping on the side of the road, which is really common in China. There we go. Bye-bye.
Could you see that car has stopped? If you do same thing in India, it'll take ages together to just reach, to your destination. In India, we have so many cars on the road. That obstacle, things is really a kind of big failure. Means IIT Mumbai, they've struggled a lot and they stopped the experiment. They struggled for almost 3 years. Like if you can get the, driverless car or human assisted car driven on the road, but no, it used to stop like, every few meters and something like that sort. Here, at least the roads are completely empty, but still that car max out at around 40 kilometers per hour. So see the difficulties, try to understand how a simple technology evolution takes time, right? We have all those sensors, means almost, 5 ladders and all those things. Each ladder costs around, $2,000. It's a costly thing, right? And it's really delicate because lasers are moving at a high speed and it's trying to gain the reflection from this laser. So this is how that lidar works, okay? Let's go take a step further.
Now our Robotaxi is turning into a rather narrow road with a stop sign. Now we've bumped into a very common situation in one of these narrow roads in China. Now we have a big truck stopping right in front of us. And our Robotaxi has carefully and smartly made a choice to go on the opposite lane to go around and run past these cars. Now, this is definitely a required skill to drive in China. Here we're entering another left turn situation where it's unprotected. Now we can see that we've got this car coming across, which is a delivery truck. We've got another home car, and also we've got a situation going across. So our car right now is trying to work out the best timing to perform the left turn.
Everybody else is going on. This car is just stationary there. The computer is just, calculating.
Now let's make the pause because we have a bike going in front of us. Now, immediately after the turn, our car makes a side pass to go around the blue truck parked in the lane. And then an orange delivery truck starts to pull over and occupies a portion of our lane. Our car wants to nudge, but has to yield to another white delivery van rushing by on our left. Now, this is a very interesting situation, and the car drove just like a human driver. Because this is a fully driverless car, what happens if you have some questions? Well, here's the help button that you can press when you have any questions, and a remote customer service will get in touch with you. Let's try and see what happens. 正在为你呼叫远程客服。已连接远程客服。为了确保服务质量，您的本次通话可能会被录音。It says that the system is connected to customer service.
您好，我是奥特尔无人车人工客服，请问有什么问题可以帮您？
Now, a human support agent has picked up the call. Let me say hi. 你好，我是在深圳体验无人车的，也没什么问题，就是想跟你打个招呼。Hello， 能看到我吗？
可以的，很高兴看到你的笑脸。欢迎来到深圳特区，来了就是深圳人。
A very nice lady said welcome to me. I'm going to say thank you to her and let her go back to work. 你们这个无人车真的很
So, we just understood like how difficult it is, right? And we are just trying to understand how much technology needs to be advanced to reach to that level. Okay. Now let's try to understand how many sensors, are there different, available as of now, or we have, Tomcast, right? Yes. Let me share this. Where's that? Yes. Now, yes. Are Kaushik, so Darshil, could you understand how the autonomous cars work? Okay, great. Ishan, have you understood how that autonomous car is worked?
Yes.
Okay, great. So what are the three basic sensors we use in autonomous car? Ishan? No, okay. Okay, let's talk about these sensors. Okay, there are, yes. Now let's try to understand how many different sensors we use normally, right? I'll share this link with you, don't worry, so that you can have a look at these website also. This is one of the most, sensor supplier across the globe, one of the most, prominent company called Thomsnet. Okay, so let's try to understand. There are some vision and imagining sensors. These are photo clicking camera. There are temperature sensors which can understand the temperature outside, inside, this side, that side, and all those things. Then there are radiation sensors, like they can sense the radiations, like radioactive radiations, heat radiations, blah, blah, blah. There are proximity sensors. These are like radars. They normally try to measure the distance between one point to another point. They are at being one point. Okay, pressure sensors. We've seen this, right? They measure the pressures. The pressures came on a particular area. Then we have position sensor like the GPS, global positioning system. We have photoelectric sensor. So what does photoelectric sensors do? If your hand is charged and you touch them, they'll tell you that there's a charge presence. They'll measure the magnitude of the charge. So these are photoelectric sensor. Particle sensors like smoke detectors, these are particle sensors. So if your air has some definite particular gas, they have something called atoms, right? We've seen atoms, molecules. Have you heard of these things? They have a specific atomic weight, they have a specific molecular weight. Now these two things can differentiate between different gaseous substances. Like for nitrogen it's different, for oxygen it's different, for argon is different, for poisonous gas is different. So how do you say you have a list of poisonous gas? You can measure these different gases available in your environment with these sensors. So these are particle sensors. Then we have motion sensors, right? Like if you're shake on it, it'll say okay, it's a shake. If you're moving, it's a moving. So they differentiate between different motion. And then there are metal sensors. So if you're touching any conductive material, then they'll tell you it's a metal present there and how much percentage and all those things, because they can basically analyze that substance to a great level. Then we have level sensors. Level sensors in the sense they can level you out. Level you out in the sense if the water is half filled, full filled, there are a list of sensors and they detect how much it's filled and all those things. Then there are leak sensors. In the scenario, if the state of a solid to liquid or liquid to gaseous, they can check these leaks. So they can check the difference in the atmospheric air, atmospheric gaseous state, atmospheric liquid state, atmospheric solid state. And that's how these leak sensor work. Then there are humidity sensor. Again, similar thing. We are trying to understand humidity in the air. Then there are gas and chemical sensors. These are similar sensors like particle sensors. Then there are force sensor, how much force, like how much weight, how much pressure, those things. There are flow sensors, flow in the sense how the liquid is flowing at what speed and those things. I'm trying to give you this list because whenever you try to create a robot, we're going to use a couple of these sensors and try to automate certain things, right? So for that, we need to understand this list of sensors. I don't want you to write it down because you can bookmark this web page, and whenever you have time, you can take a list and try to understand how these sensors are different from one to another. Okay, so we have flow sensors, we have flaw sensors. Flaw sensors in the sense solid, crack, solid. So they try to measure how dense is the atomic structure is and where there are flaws and all those things. Then there are flame sensors. They try to find the particle of fire in the air. That's a flame sensor. Electrical sensor, if the charge is present and then how much quantity. Contact sensors, so if there's actual touch or it's just motion, those kind of things. And non-contact sensor, so you can just have something like, I'm showing you my hand, I'm moving my hand. Computer or the radar plus camera can understand these movement and then they can work effectively. If there are some keyboards they are trying to create where you can just type it on a glass surface and try to guide computer on that keyboard rather than pressing a particular button. They are still working on it. It's called gestured keyboard. They're still evolving. These sensors are also evolving, right? So there are these, I'll post this link in our WhatsApp group so you can have a look at it whenever you have a time, or whenever if you want to study a particular sensors, you can go to this site and try to understand what are these sensors do, right? These are different sensors we are talking about. Okay, any confusion at this moment? Anything you couldn't understand or need some additional details? I know it's a bit technical, but we need to go to this technicality. Otherwise, it's difficult for us to understand how the machine will understand anything, right? So these sensors help these robots to understand certain things and then take the decision based on that understanding. So have you, got the importance of a sensors? Any confusion there? Could you try to explain me a situation where you can use a sensors in your home? Any sensor for that matter. Kaushik? Right? So she logged out. Darshil, you might need to chat. Could you type it out? Your mic is on, but I couldn't hear you. Pardon me for that. Is this mic on your headphone by any chance? No, yeah, it's this headphone. No, no problem. It's there, but I still couldn't hear you. Okay, great. Could you think of anything, any sensors uses in your day-to-day life? Okay, which type of sensor? Humidity sensor, right? Very right. You can do that, or you can have something like camera, so that you can see if somebody is coming, and you can have a LCD inside, so you can have those like a remote vigilance, or remote security door kind of scenario as well. That's great. That's good. That's really great applications. Great. Uh, Thank you. Thanks a lot. Okay. I think Kaushik is not there. Ishan is not there. I don't know what's happening. Let's go back to our presentation, or let's stop here. I believe it's almost an hour, right? And let's meet on Monday. Let's try to understand in depth. We'll just revise this thing, and then we'll understand the actual intelligence applications in the world. Does that make sense? Sure. Thank you. And I'll basically share a link of this video so you can download, right? And you can have a look at it again. I'm going to share the link of the video also, whatever I've showed to you, so that you can, yes, I'll do that on WhatsApp. Thank you, Darshil. Thanks a lot. You have a good night. Bye. Take care. Thank you.